This is Alovergal Alex, and today we're going to be talking about the foundations of vector calculus, which, unsurprisingly, is vectors. So we'll start here. I'm assuming that you all understand what 3-space is, so if you don't understand what 3-space is, you can search it up, Google it, ask ChatGPT, whatever. Okay. So the question that we must ask ourselves is, what even is a vector? So what is a vector? So glad you asked. A vector is an object that has a magnitude, also known as length, and a direction. So, if I were to tell you to walk 2 units forward in 3-space, which is where we live, how would you know if I was asking you to walk north, east, south, or west? 3 units forward is completely arbitrary. So one solution to this is to define objects called vectors, and vectors can pinpoint points in 3-dimensional space for us. So if we think about 3-space, this is the z-axis, the y-axis, and the x-axis. If I have this point here, I can pinpoint where that point exists in 3-space with some arrow here. Now this arrow represents what we call the position vector of this point P. Let's say P is A, B, C. Then this vector here allows us to tell you exactly where this point is in 3-dimensional space. This is one example of a vector, but vectors don't have to just be position vectors. They can be vectors existing just in 3-space however as they please, and we'll get to vector fields later. So, now that we know what a vector is, let's talk about notation. Okay. So the notation that we use for vectors is either an arrow over the letter. This is reserved for what we call unit vectors, which we'll get to in the next video. This is a little hat, or, which I will try my best to draw here, bold lettering. You see this in some textbooks, but sometimes it's more common to use the arrow notation. So I would note that a vector is not a scalar. So vectors, I'm gonna use a different color. Vectors are not the same thing as scalars. Now, what is a scalar? A scalar is a number. It doesn't have a direction. It just is a number, like the number 2, or the number pi, 3.14, or any other number. It doesn't encode anything about the direction. So for example, piggybacking on our position vector, the position vector v located the point P, which I called A, B, C. Now A, B, and C are what we call scalars. The vector v, that was a position vector that located this point, is not a scalar, because this vector includes a direction, right? That arrow, if you remember that arrow, and it includes a magnitude, which we'll get to in the next video.